Hello everyone, myself Deepa Singh, working as assistant professor in Suresh Gyan Vihar University. Today we discuss about solid dispersion technique. This is a technique which you check with the help of certain technique or certain methods. And this topic covered in pre-formulation and first unit of industrial pharmacy 1 syllabus. So in this solid dispersion technique, before starting this solid dispersion, you know this basic objects. In this object, first is definition of solid dispersion. And in this, you know about what is solid dispersion and why the solid dispersion is important. Next is method of preparation of solid dispersion, different techniques or different methods used for solid dispersion and how you perform these techniques. And the method of determination of a solid dispersion, how you check this method with the certain techniques or certain methods for solid dispersion. And pharmaceutical application of the solid dispersion. In this, you know that various application of solid dispersion or how you check the solid dispersion or various field in the solid dispersion technique is used. In solid dispersion system, definition of solid dispersion is defined as a dispersion of a one or more active ingredient in inert carrier or matrix prepared by melting solvent or melting solvent method. Means in solid dispersion, maybe you take one or more than one active ingredient or more than one excipient as an inert carrier or mold matrix, and you prepare solid state solution or a mixture by the help of different techniques like melting solvent or melting solvent method. Means maybe use only melting method or maybe solvent method or maybe in the combination of melting and solvent method. Means with the help of one or more than two ingredient, you just prepare a mixture, and that mixture should be in a solid state. Or for this preparation of a solid state mixture, you take maybe different methods, melting solvent or solvent melting method or maybe individual method. In this next is classification or based on the fast release mechanism. In this first is simple aquatic mixture, solid solution, glass solution and glass suspension, amorphous precipitation of a drug in crystalline carrier, compound or complex formation between the drug and carrier, any combination among the above. In this may be used about previous for the starting method, in a combination, maybe individual method or in a combination method. So these are the different methods of solid dispersion depending on the mechanism of release. Now we discuss this individually. First is aquatic mixture. In aquatic mixture, when two or more substances are mixed together, they liquefy due to lowering of a melting point at the individual melting point. Such substance is called as aquatic substance. Means in aquatic substance or aquatic mixture, take two or more than two substances mixed together until it gets liquefied, and you reduce the melting point of that particular substance or individual melting point of that particular substance. Such a substance are called as aquatic substance. And example of this aquatic is paracetamol, urea, and disulfiram is the example of this aquatic mixture. And in this first, the simple binary phase diagram showing aquatic point E and the aquatic position at the point E of a substance. A and B represent the melting point. Means you can see this diagram. E is the aquatic mixture point of any compound or any substance, and A and B are the two melting point of that aquatic composition or aquatic mixture. In this, TA and TB are the melting point of pure A and B. This is a pure melting point A and B, and this is aquatic mixture of A and B compound, and it's a aquatic compound point E where the both A and B gets met, or you can see this different to melting point temperature A and B. In this, the following factor may contribute to faster distribution rate of a drug dispersed in aquatic mixture: increase in drug solubility, solubilization effect by carrier, which completely dissolve in short time in a diffusion layering surrounding drug particle, and absence of aggregation agglomeration between fine particles of a poor hydrophobic drug. Means in this, you know that when you use this aquatic mixture technique, the solubility of the compound may be increased or it show more efficacy or completely dissolved by the surrounding compound or diffuse with surrounding compound, and absence of aggregation or agglomeration between the fine particles of poor hydrophobic drug. Means in this aggregate do not form or do not aggregate, it should be formed in a free form. And in this, excellent spreadability and dispersibility of a drug as encircling soluble carrier readily dissolve and cause water to contract as wet drug particle. In this, your compound or your drug interact or show some metability or dispersibility with solvent or any other liquid carrier. With the help of this metability and dispersibility, it get easily dissolved and form the solution because it easily contact with a certain particle or easily disperse due to their metability. Next is crystallization of a drug in metastable form after solidification from fused solution which has a high solubility. And in this, if you use crystalline metastable form, it show more fused solution or higher solubility compared to any other one. And aquatic are easy to prepare, economical, with no solvent involved, and this method, however, cannot be applied to drugs which have failed to crystallize from mixed melt, thermolabile drug, carriers such as succinic acid and decompose of the melting point. And this method is very suitable and very good method, and as well as economically also possible. We do not take too much large economy or large cost, and no solvent is required. You just take a compound and no restrictions. Suppose your drug is failed to crystallize in a mixed melt, and a thermolabile drug, those who are heat sensitive, when you use this method, it gets degrade your compound due to sensitivity with heat. And the carriers such as succinic acid and compose at melting point, and those compound like succinic acid which decompose at particular melting point. So these compound you do not use by this aquatic mixture technique. And next is solid solution method. Second method, it is a made up of a solid solute dissolved in a solid solvent, and it often called as mixed crystal because two components crystalline together in homogeneous phase. It is prepared by fusion method. Means in this you also don't use any solvent or liquid state solvent. You just prepare a solution with the help of both solid compound. Maybe your solute should be in a solid state and solvent as well as also in solid state. Means you mix solute and solvent, both solid and solvent in a solid state, and you prepare a mixed crystal of these two solid components or compound. This homogeneous mixture is prepared by the fusion method, and a solid solution of a poorly soluble drug in rapidly soluble carrier achieve a faster dissolution because particle size of the drug is reduced the molecular size. In solid solution, poorly soluble drug, rapidly soluble carrier achieve and faster dissolution. Means in the solid solution, you see that with the help of the solid solution, dissolution rate is more and the faster dissolution it takes place because particle size is reduced or molecular size of the particular particle is reduced. If particle size gets reduced, it show more surface area, and more surface area helps to show more fast dissolution rate. So if you use this solid solution technique, it directly affects your dissolution rate and show more dissolution or fast dissolution. And in this technique, just take solid state solute and solvent. No need to use any liquid solution or liquid solvent or solute and solvent. You just take both solute and solvent in solid state and mix together with the help of fusion method. Next, classification according to miscibility. In this, first is continuous phase and second is discontinuous phase. In continuous phase, isomer unlimited, complete and solid solution. And in discontinuous, just opposite to continuous phase, it's a limited, restricted and incomplete solid solution. According to crystalline structure of the solid solution, substitutional solid solution, interfacial solid solution, these are the two types. And in continuous solid solution, the two components are miscible or soluble at solid state at all proportion. Means when you take two compound in a solid state, one is solid and second is solvent, it completely miscible or solubilized with all portion, and both are in a solid state and in a continuous phase, and no established solution of this kind has been shown exhibit fast release in dissolution property. It should be show more fast release or more dissolution property, and the faster dissolution rate would be obtained if the drug is present and as a minor compartment. And in the discontinuous solid solution, there is only limited solubility of the solute in a solid solvent in this group of solution. It's just opposite to continuous. It's not in continuous phase, and there's only limited solubility or specific solubility with solid solvent or any other solvent, and this is known as discontinuous solid solution phase. Third technique is glass solution and glass suspension. In this technique, a glass solution is a homogeneous, glassy system in which solute is usually obtained by So glass solution is homogeneous and glassy system. And so you just take glass solution of two compounds, and both compounds are in a solid state, and prepare glass solution, which is usually often by applied quenching of a melt. And many compounds are shown to able glasses readily upon cooling from the liquid state. And so you just take two solution and prepare homogeneous solution and readily cool the particular compound. When you cool this compound, it will show glossy liquid state solution, and it have a more solubility and more absorptivity compared to the previous one. And these compound include sucrose, glucose, ethanol, and 3-methylcycline are the example of glass solution and glass suspension. It is a permissibility due to their strong hydrogen bonding, and which may prevent their crystallization. And polymers possessing linear flexible chain can freeze into a glass state and to transparency and bitterness, means in this personally due to the strong hydrogen bonding, and which may prevent the crystallization. This is mainly solid solution and suspension occur due to the strong hydrogen bonding or strong hydrogen bond present between the structure. And polymer possessing linear flexible chain and can freeze in a glass state to transparency and bitterness. They show more transparency and bitterness. They are easily break or show more transparent solution or linear flexible chain, which can easily freeze. The strength of chemical binding in a glass solution is much less compared to that kind in a solid solution. Means in this chemical binding, the glass solution is showing less strength and compared to solid solution. They have a don't enough strength compared to the previous one. They have a less strength and easily break. And dissolution rate of this drug in glass solution is faster than in solid solution. But in this dissolution rate of that particular drug in a glass solution is faster in solid solution compared to any other solution. And example is glass solution of citric acid. Next, D1 is amorphous precipitation of a drug in crystalline carrier. In this amorphous precipitation of a drug in crystalline carrier, instead of forming simple aquatic mixture in which both drug and carrier crystallize simultaneously. From a salt method of precipitation, the drug may also precipitate out in amorphous form in crystalline carrier. Means in this you just prepare solution, or instead of preparing aquatic mixture, in aquatic mixture we take two compound solute and solvent, both are in a solid state. But in this, you take any other solution instead of aquatic mixture, both drug and carrier crystallize simultaneously. And from the solvent method of precipitation, the drug may also precipitate out in amorphous form and in crystalline carrier. Means there may be chances it converted into amorphous form or maybe in a crystalline form. It has a faster dissolution and absorption rate than crystalline form. This method is also show fast dissolution, and previous method solid solution and solid dispersion suspension also show fast dissolution rate. And this method is also the same dissolution rate, faster dissolution rate, absorption rate than crystalline form. And the example of this method is amorphous novobacin has 10-fold higher solubility than its crystalline form. And so if you prepare this novobacin amorphous form, it shows more solubility and approximately 10 times or more than 10 times compared to crystalline form. So you can use this novobacin in amorphous form if you require more solubility. If you maybe use this novobacin in amorphous form, it may be also use less dose, or you can take less dose compared to the crystalline form, because when you prepare in a crystalline form, it requires far more time to dissolution, and maybe chances that it should less absorption or slow release. Next, E method is compound or complex formation. In this, dissolution and absorption of a drug can occur from a complex or a compound formed between the drug and inert soluble carrier. Name of this method itself explains compound and complex formation. Means in this you prepare just compound of one or two or more than two solute and solvent, or maybe form the complex. And due to this complex formation, dissolution may change or show more dissolution rate or fast dissolution rate. When dissolution is more, then absorption is also fast, takes place. And in this dissolution method, in this complex and compound formation method, dissolution and absorption of drug can occur from a complex compound between the drug and inert soluble carrier. Complexation also implies that dissolution could be retarded, observed with PEG 4000 phenobarbital. Means with the help of PEG 4000, polyethylene glycol 4000 phenobarbital. Complexation method also takes place, and when you use this pH 4000, it shows more fast release or fast dissolution. However, the formation of a soluble complex with a low association constant result in increased rate of dissolution and absorption. And these soluble complexes form, and it show constant release or constant dissolution, fast dissolution rate due to this complex formation. So this method is very useful and show more dissolution rate as well as absorption with the help of PG4000. And especially when you use this PG4000 with phenobarbital drug, it show more dissolution and form the complex. Next, F1 is combination and miscellaneous method. In this combination and miscellaneous method, a solid dispersion entity belongs to any 5 group discussed so far, but it can also be made of combination in, of different groups. And these combination increase the dissolution and absorption rate. And in this, the disciple will discuss is a high concentration increase existence, individual molecule and such microcrystalline particle. Means in this method, you can take combination of previous method or before you maybe take individual method or in a combination of 2 or 3 method. In this method, you make a solid dispersion entity belong any 5 group, and it can be made combination with different group. Not only take single group, maybe use in a different combination group, and this combination increase the dissolution as well as absorption rate. Example in this PG, and PG mainly use the glycophyllin drug, and when you use this glycophyllin with PEG, it form microcrystalline particle, and this microcrystalline particle show more dissolution rate. Next is method of filtration. In this, there are different types of method of filtration. First is melting method, second is solvent method. The melting solvent method, it's a combination of both melting and solvent method. Then next is cold mat extrusion technique. These are the common methods for solid dispersion. This melting method or fusion method, the physical mixture of the drug and water soluble carrier is heated until it melts. Means in this technique, you just take the physical mixture of your drug and water soluble carrier. Carrier should be in a water soluble, and your solvent is in physical state or physical mixture. The melt is then cooled and solidified rapidly in ice bath, vigorous heating. After this mixing of solid and solvent, you just cool this solution or solidify with the help of ice bath or by vigorously heating, so stirring. Then final solid mass is crushed, vaporized, and sealed. After final this solid mass was vaporized by the seal method and facilitate faster solidification. The homogeneous melt is poured in the form of thin layer onto the stainless steel plate and cooled by flowing air on the water on opposite side of the plate. In melting method and fusion method, just to take the first physical mixture of a drug and water soluble carrier, and after this solution is formed and mass is formed, you just cool the solution or cool this solidified solution with the help of ice cold or by vigorously heating, and after cooling, you just pass this final mass with the help of crush or vaporized or by the seal method. And this seal method again solidify by spreading thin layer onto the stainless steel plate, and this cooling takes place with the help of air or water, and you use this water and air just opposite side of the plate, and with the help of this air and water, there's a thin layer of this solution is formed. Advantages of this method: simplicity of the method, supersaturation of the solute, and in the system can be obtained by quenching the melt rapidly from high temperature. Means this method is very simple, no trained person or specific person is required. Anybody can perform this technique, and very simple method. In this method, no specific conditions required, and it easily performed in lab scale also. And disadvantages: some drug carrier may decompose or evaporate during fusion process at high temperature. In this technique, there's one disadvantage is when you heat this compound or this solid and solvent at high temperature, it may chance it will degrade or maybe change their structure during high temperature. This is mainly occurred due to heat sensitive compound, heat sensitive material, which do not show stability at particular temperature. So this is one disadvantages. Example of this disadvantages is Succinic acid used as a carrier for glycerol is quite volatile and may be partially decomposed by dehydration and near its melting point. When you use this method with the succinic acid and glycerol, and this one is volatile in nature, and when you use this melting method, it they partially decompose or show their structure changes due to dehydration and gets melt and don't have the specific structure due to the high temperature. So first to check the compound should be heat stable or not. It should not be thermolabile. And if not thermolabile, then use this method. And this method is more easy, more convenient, and less economical. And no trained person is required. Only disadvantage is that we do not use for heat sensitive material, thermolabile material. Next is solvent method. They are prepared by dissolving a physical mixture of a two solid component in a common solvent, followed by evaporation of the solvent. This solvent method we use or we dissolve the physical mixture of a two solid compound with the help of a solvent, evaporation of the solvent. Then so you take two compound, both compound are in a solid state, and you add this two solid compound in a solution and the solution is in liquid state, and after evaporation is taken place between the solvent. And the method is used to prepare solid dispersion of glycerol, polyvinyl chloride, sulfathiazone, PVP is the example. Solvent method means we take both compound in a solid state but use liquid solvent for dissolving purpose. But after dissolving, you evaporate all this liquid solvent, and after evaporation, we use this particular compound. And mainly this technique is used for compounds like or drug like glycerol, polyvinyl chloride, sulfathiazole, PVP. Advantage of this technique is thermal decomposition of the drug or carrier can be prevented because of low temperature required and evaporation of organic solvent. Just opposite to previous one. In previous technique, we take a higher temperature for drying or before preparing this. So in this, there is a limitation is we do not use this technique for thermolabile or heat sensitive material. But this technique have its own advantages is that we use this technique at low temperature. So there's no chances to it get degrade or show any decomposition between your compound or between your drug. And evaporation of organic solvent is also takes place. Disadvantages of this technique is high cost of preparation, difficulty in completely removing the solvent, difficulty in producing crystal form. This technique is require more costly, economically costly compared to previous one. And this when you remove solvent or evaporation takes place, that when you don't assure or don't assure that about if they remove completely or it's in a dry form, then the chances small amount of moisture or solvent is maybe present in your solution. So you do not assure 100% that all complete solvent are removed by this method. And difficulty to produce crystal forms. There may be chances it form amorphous or maybe improper crystal form. It do not give proper good crystal form and difficult to form the crystals. Next method is melting solvent method. In melting solvent method, it is prepared by dissolving the drug in a suitable solvent and then incorporating this solution in a melt of PEG without removing the solvent. In this technique, first you dissolve your drug in suitable solvent, and this solution is melt in PEG without removing the solvent. In this method, you remove the solvent, but in this melting solvent method, it's opposite to second one method. In this, you do not remove the solvent. Just take your drug and dissolve in a particular solvent, and after dissolving, you add PEG, melt of PEG, and you do not remove the solvent. And advantages of this method is it have a two method, and disadvantages is from practical standpoint, it is only limited to drug with low therapeutic dose, below 50 mg. Actually, we can say that this method is very good method compared to this previous two methods, and this is almost same method, but there is difference is only that in this method we do not remove solvent, so we do not take tension that all moisture is removed or not, or solvent evaporate or not. And this method is similar to before to previous method. But disadvantage of this method is that you do not use for all drugs. You would only limited drug. Most drug whose therapeutic dose is below 50 mg or at least 50 mg. Above 50 mg drug therapeutic dose, you do not use this melting solvent method. Otherwise, this method is very good method. Next method is hot melt extrusion method. In hot melt extrusion method, in this method, a blend of active ingredient, polymeric carrier, and other processing aids like plasticizer, antioxidant is heated and softened. In this method, certain additional excipient used like plasticizer, antioxidant, and heated this you heated this solution until it gets soft. And polymeric carrier is also used with this excipients. Means in this, first to blend all active ingredient, and in all active ingredient you also include polymer as well as plasticizer, antioxidant, and you heat all this excipient until it gets soft. And this softened material is called as extrude, and this mass when the extrude is cooled at a room temperature, the polymer thermal binder solidify and bond the excipient together to form a matrix. After forming or after softening the solution, you form extrude, and this softened material is known as extrude. And you cool this extrude at room temperature, and polymeric thermal binder solidify and bond excipient to form the matrix. Means in this method, first to prepare one mass of one extrude, and this extrude include all excipient, plasticizer, antioxidant, and any other excipient in a combination, and you heat this all and it gets soft. And when it gets soft, you see that the one soft mass is formed, and this soft mass is called as extrude. And after this, you dry and cool this extrude at room temperature, and then polymeric thermal binder you use for solidification and excipient to form the matrix. Those above excipient that you use in this technique helps to form the matrix, which is in solidified form. Next is advantages of this technique. In this technique, there is no concern with solvent handling with recovery after processing. Means in this, there's no concern with solvent handling and recovery after processing, and it is a simple continuous process for preparation of a tablet and granulation. The process is faster. There were fewer steps than wet granulation method, and can be used for formulating sustained release granules. In this technique or this method is mainly used for the formulation of solid dosage form or tablet or granules, and this method is mainly used for sustained release granules. And in this process, you see that it is almost similar to wet granulation, only some steps are steep, and the process is in continuous formulation process, and tablet and granules are prepared with this method, and no specific solvent handling is required. And recovery is also takes place by this process. And example of this process is diazepam granules. Next is methods of determination of a solid dispersion method. In this, first is thermal analysis. In thermal analysis, first is cooling curve method, second is thermal melt method, and one is thermoscopic method. And one is different thermal analysis and DPA, and one is zone melting method. Now we discuss this one individually. In methods of determination, there is some technique like X-ray diffraction method, microscopic method, spectroscopic method, thin layer chromatography, solubility determination, all these methods. Now, first one is thermal analysis. In thermal analysis, is used to study the physical-chemical interaction of a two or more compound. And principle is change in thermal analysis function of a temperature. This thermal analysis may be performed with the help of a temperature. When temperature gets changed, and then if reading show changes with particular temperature, and the response is observed with respect to temperature. And in this, to use two or more compound for evaluation. In this first thermal analysis method is cooling curve method. In cooling curve method, the physical mixture of various composition are heated until a homogeneous melt is obtained. Meet all this physical compound until it forms homogeneous solution, homogeneous mixture. The temperature is mixture recorded as function of the time. We just start heating of all mixture until it reaches at a specific time point, and we record this temperature or changes takes place at particular temperature. Next is thaw melt method. Here is simple solidified mixture in capillary melting point 2 is heated graduate till the throw point, and throw point is referred to crossing the solidus line. It is a useful to diffraction between the simple aquatic system and limited solution. It is opposite to previous one. In this, you solidify the mixture with the help of melting method or heated the temperature gradually with the help of throw point, and this is crossing the solidus line and differentiate between this aquatic system and limited solution. This takes place with this throw point method. Next is thermoscopic method. In thermoscopic method, polarized microscopy is used with hot stage to study the phase diagram of binary system, and the physical mixture is gradually heated on a solid state and slide until it completely liquefied. After cooling, the mixture is heated at a rate of 4 degrees per minute and through and melt point at the time of visual observation. It's a very simple method. In thermoscopic method, first to take polarized microscopy and stage microscopy for phase diagram of binary system. Then you heat this physical mixture gradually on a slide until completely liquefied. And so now put your sample on a glass slide and heat that compound until it gets liquefied. And after liquefied, to cool this solution of this mixture, and after this heat it again, and heating is takes place at 4 degrees per minute. Means you increase every minute 4 degrees Celsius temperature, and after this heating you use the thaw or melting point to determine visual observation. No specific machine or instrument you use. The visual observation takes place after this heating. Next D is differential thermal analysis or DTA, an effective thermal method for studying phase equilibrium of either pure compound or mixture. Different effects associated with physical or chemical change are automatically recorded as a function of the time or temperature as a substance is heated in a uniform rate. In this method, addition, evaporation, sublimation, polymerized transition, dissolution can be detected. In this DTA method, various type of phase is achieved, and this is a pure compound method of pure mixture based method, and then this is mainly you take place with the help of physical chemical changes, and when physical or chemical changes are takes place, it record automatically all readings with respect to time and with respect to heat. And other than this, there may be some other methods that also takes place like addition, evaporation, and sublimation. Polymorphic transformation and dissolution is also detected in DTA. Next is zone melting method. It is a primary use for ultra purification of metal and inorganic metal. This method is limited for limited compound, and mainly this method is only used for metal or inorganic organic metal. Next D1 is X-ray diffraction method. In X-ray diffraction method, the intensity of X-ray diffraction or diffraction from a sample is measured as a function of deflection angles. Counter and cell method detect diffraction intensity, and counter method provide a better resolution of the diffraction and relative intensity, which may be easily compared. And these methods use characterize the physical chemical properties of the various film in dispersion PG and 4000 6000. This X-ray diffraction method is very simple and very easy method. In this method, you determine a particular compound of solid dispersion, but the readings is recorded with the help of X-ray. And the X-ray light get diffracted to particular compound, and this method is mainly used to characterize certain type of compound. Example is like crucifulvin. And the crucifulvin disperse in the pH 4000 to 6000 compound. And in this technique, we measure a sample with the help of reflection light of UV or maybe deflection light of the UV according to angle changes, and detect the intensity of compound also. And this intensity shows resolution changes or certain intensity changes. You just compare or easily check this intensity changes with the help of reflection. Next is microscopic method. In microscopic method, it has been used to study polymorphism, morphology of solid dispersion, and the fine particle of a crystalline in a glass PVC can be easily detected by polarizing microscopy, and the resolution of electron microscopy was used to study dispersed particle of inorganic. spectroscopic method. In the UV study, the spectra of a pure drug and dispersed drug are scanned. In spectroscopy, mainly you use UV light or ultraviolet light, and your compound should be in a pure state. If it contains certain impurity or coloring agent or any foreign particle, there may be chance that this reading of also may be recorded. So you should take always pure form during the spectroscopic method. And if your product is not in pure form, then first to purify it. Otherwise, the reading may vary, and it get record that impurity material reading. And it should be dispersed drug are scanned properly. An example of this spectroscopic method is spectrum of the dispersion beta carotene. Resembles that beta carotene is dissolved in organic solvent and but do not indicate that molecular dispersion of a drug in a polymer. This is an example. And beta carotene resembles that beta carotene is dissolved at particular organic solvent, but do not indicate molecular dispersion with drug or with a polymer. So you always take your solution of your mixture of this solid dispersion when you use this spectroscopic method. Now, thin layer chromatography. ELC characteristic of a pure and dispersed drug are studied to test whether the drug are decomposed by process, and single spot with the same RF value is expected for both the pure and processed sample in thin layer plate. This thin layer plate is rarely used only depending on the certain type of formulation, and but this PLC mainly used for pure and specific type of drug which decomposed by the heating method or certain high temperature. And in thin layer chromatography, we check RF value, and with the help of this RF value, just calculated your result. And this RF value you calculate with the help of spot technique or a single spot technique, which you mark on the TLC plate of particular sample and check how much it travel from starting point and end point. And with the help of this spot travel by the compound or drug, you check the RF value. Next is solubility determination method. In solubility determination, result from active solubility study of a drug in various concentration of carrier would indicate interaction between the drug and carrier. Such a study indicates weak and insignificant interaction between reactive fluid KZ6000 and increased rate of dissolution due to solubility of the drug by carrier can be predicted by this method. In this method, example is mainly for weak or insignificant interaction takes place. Example is cruciferin and KG6000 mainly. And in solubility determination, we just check solubility of a particular compound or particular solid dispersion with the help of certain carrier. And in this method, there's chances interaction is also takes place between the drug and carrier. So first to assure that the drug should be in a pure form and it will not get interact with your carrier. And in this interaction, maybe affect the dissolution rate or solubility of the drug also. So before starting this technique, we should assure about the interaction or compatibility between carrier and drug. And if it's all is okay, then this method is mainly used to increase the rate of dissolution due to solubility of the drug or the carrier. And you use this method very easily. There's no specific instrument or trained person is required. These are the pharmaceutical application of a solid dispersion. This to obtain a homogeneous distribution of a small amount of a drug at a solid state. Hence, when you use this solid dispersion technique, it forms a homogeneous solution or a solid state solution. And to stabilize unstable drug, if your drug is unstabilized, it also change their stability and convert it into stable form. And to disperse liquid or gaseous compound, easily disperse the gaseous or liquid compound or easily solubilize the liquid and gaseous compound and formulate a faster release chromosin dose in sustained release dosage form. This method is also used for sustained release or controlled release type of formulation because it should faster release the chromosin dose, remaining dose for particular sustained release formulation because it shows longer period of time effect because you modified the formulation, and that's why it shows long period of a time effect. And formulate sustained release dosage form for prolonged release regimen of a soluble drug by using poorly soluble or insoluble carrier. And this will also prepare sustained release formulation with the help of poor soluble or insoluble carrier. This is all about the application of solid dispersion. So solid dispersion method is very important. You can change your formulation or design your formulation according to different types of solid dispersion technique. These are the learning outcomes. In this learning outcomes, after completing this topic or after completion of this slide, you know about all this thing about solid dispersion, what is solid dispersion, definition of a solid dispersion, how we perform the solid dispersion, and different methods for solid dispersion, and how you determine the solid dispersion, and the application or advantages and disadvantages of a solid dispersion technique. We already discussed different types of techniques like aquatic mixture, solid dispersion, or solid suspension, and different evaluation method of the solid dispersion. So in this solid dispersion, mainly we can say that we use solid and solvent in a solid state, and in very rare method we use solid and solvent or maybe single phase in a liquid state, but you use mainly in solid state, both solid and solvent, and you also use some solvent, and if you use this solvent, maybe it get evaporate. If it do not evaporate, then you maybe check the other method, or maybe you use any further method for evaporating this solvent. So almost all methods are similar. There's little bit difference between all these methods. So you know individual this solid dispersion method and difference between each solid dispersion method. Why this method is more appropriate or more good, and why we select this method. And according to different types of the drug or different type of formulation, we select this solid dispersion method. And before selecting this solid dispersion method, you are sure about your drug is compatible with particular drug or not. Suppose your drug is thermolabile, then you select your solid dispersion technique according to this thermolabile drug. If you do not select this according to this thermolabile type, then maybe chance that your drug or your compound may degrade or maybe show decomposition due to high temperature or high heat. So you should know all this method or difference between these methods, and the selection is also very important according to the type of drug. Next is reference part. In reference part, pharmaceutical pre-formulation, the physical-chemical property of the drug substance by James Abels, Ellis, Howard's Limited Publisher, Chester, page number 21 to 26. And second reference is Ansel Pharmaceutical Dosage Form, Drug and Delivery System. Eighth edition by Lord B. Allen, Nicholas C. Popovich, Howard C. Ansel, published by BA Publication PVT Limited. Page number is 187 to 193, 42 to 43, 126 to 133. And third reference is Pharmaceutical Pre-Formulation by J.T. Cartesian, published by Technomic Publishing Co. Page number is 126 to 11 to 12. Next, fourth reference is Textbook of Physical Pharmaceutics by C.V.C. Subramaniam, published by Balla Prakashan. Page number is 18208 and 222 to 26. Next reference is the Theory and Practice of Industrial Pharmacy by Leon and Lackman, Habas, Lieberman, Joseph L. King, third edition, published by Legacy Publishing House. Page number is 171 to 184. And next is Martin Physical Pharmacy, Pharmaceutical Science, fifth edition by Patrick J. Simcoe, published by Lippercourt William, Princeton, page number is 547 to 550. And next reference is Pharmaceutical Dosage Form, Tablet, Volume 1. And edited by Heppers, Lieberman, Leon, and Blackman, published by Marshall Decker, page number 1 to 10. This is all the reference of this particular solid dispersion technique. You may use single book or maybe in a combination book, or other than this book, some other book is also available. And now the question. First question is the property include color, odor, appearance, and taste, use, and properties of excipient that make the drug are more palatable. In this, A option is optical counting method. B is hot stage microscopy. C is sedimentation technique, and D is organoleptic property. Next, second question is these are the more precise method for determining lighting method. The major ways change into qualitable data is A option organoleptic property, B is DSP and DTA technique, C is equilibrium solubility method, D is sedimentation technique. In third question, all oral solid dosage forms show greatest chemical and microbiological stability. B is more impurity, C is more administrative problem, D is more irritation. And fourth question is drugs that are sensitive to oxygen may require A is encapsulation or coating, then binder, maybe diluent, and then sugar coating. Next, fifth question is microscope. Crystalline cellulose, also known as HPMC. D is CMC. C option is PVC, and D option is abyssal. And sixth question is acrylate polymer, is also known as A ethyl cellulose. B is ultraject. C is hydroxycellulose. D is carbopol. Seventh question, why emulsion dosage from mucopolysaccharides prove better? A option is easy manufacturing. B is higher stability of the drug in emulsion form. C is presented a large surface area of the oil plus GIT from the absorption of the drug. D option is fast clearance from the plasma. Next, eighth question is what is the major rate limiting step in absorption of the drug from suspension dosage form? The option is tablet to disintegration to granules. B is granules disintegration to fine particles. C is fine particle dissolution, and D is dissolution absorbed into drug. Next, ninth question, in the stability of the emulsion, which imparted in stability state should be prevented. A is breaking, B is pole census, C is flocculation, D is creaming. And 10th last question is Brownian movement of the particle in suspension cause. A is assist segmentation, B is promote segmentation, C is prevent segmentation, and D is increase segmentation rate. This is all about question part. So thank you everyone. Thank you for listening and watching this video, and thank you so much.